Good morning, this is Deep Generative Models. Today we are going to talk about the autoregressive model. We'll have a few videos on this topic, and this is the first one. I'll give you a brief overview on this topic. Like always, all notes and reference will be on our course website, tjwei.tw. So why is this topic, the auto-regressive models, relevant to us, or why is it important? There are many different motivations that can lead us to this topic. Like I mentioned in last week, in the context of generative AI, we are usually dealing with some object that has a very complicated structure of probability distribution. So like an image, each pixel of the image are heavily correlated to each other. So if they are not correlated, if each pixel are unrelated, then things get pretty easy because we can generate each pixel independently and then put them together. That would make things pretty easy. However, it is not the case. If we really generate each pixel independently, no matter what method you do, if you then put all the pixels together, then you will get just some noisy image, kind of like all of the garbage, put them together. So one way to deal with this kind of complicated structure of probability distribution is to use autoregressive way to fill this probability distribution. So that's why autoregressive is an important method or direction that we can try or to attack this kind of complicated probability distribution. It is also an intuitive way or straightforward way if you really know what it is. So another reason that it is important to us is, in fact, ChatGPT or GPT in general is an autoregressive language model. So this is the GPT-3 paper. So you can see that in the abstract, it actually literally says that GPT-3 is an autoregressive language model. So what is autoregressive means? So you can often heard that people, some people, not all people, not perhaps not many people, but some people like to criticize ChatGPT or large language model in general. So there are some phrases that are overly used to criticize this generative AI, like it is nothing but a glorified autocomplete. You are just it is just a stochastic parrot, or it is a poorly compressed JPEG. So actually, this description of generative AI is not wrong. It is just that generative AI or AI in general is a very huge and a topic that we are not currently fully understand. So we need different aspect to fill it. So by filling, the most relevant phrase here is the first one, the glorified autocomplete, because auto-regressive model or auto-regression is pretty much the same as autocomplete, at least in some case. So by saying it is just a glorified autocomplete, or by saying ChatGPT is simply a autocomplete, it feels kind of neutral to me, because it sounds to me ChatGPT is nothing but a autoregressive model. This is actually true, because like we just mentioned before, it is literally true. the paper actually says GPT-3 is an autoregressive language model, and autoregressive is pretty much just autocomplete. So it is nothing wrong about it. There's nothing wrong about it. It just kind of remind us that maybe we kind of underestimate what autocomplete is. Maybe if you use the autocomplete method, I mean, we have autocomplete in our daily life. When you type something or on your phone or even on your computer, it will, or in a Google search, box, the computer will do the autocompletion for you. It is so common that we kind of feel it like nothing. But just like what the ChatGPT has already demonstrated to us, that if we use autocomplete or autocompletion, auto-regression intensively, maybe it can achieve something that beyond us imagination. So I kind of feel this as a reminder, not a totally negative way. So what exactly is the autoregressive model? So if we feel like in the formula, it is simply this formula. So basically, it is what we want to do is to predict the next item, or consider a sequence of items, which we call it a time series. Like we have x1, x2, x3. So for just say, for example, for each second, we get a new value, or maybe it's just a number, or maybe you can put it as a letter. But if you consider it's a number, for each second we get a new number. So suppose at the 10 seconds we already get 10 number. So if we wish to predict what comes next, if we have a model to do so, then this model is called autoregressive model. On the other hand, if you see this, if I consider a sequence, this sequence can be a sentence of text, of words, a sentence of or even a sentence of characters, or simply a sequence of numbers. So we just got a huge sequence of number. Each items in this sequence, each component in this sequence or each element in this sequence are correct to each other. So they are not just some like what we would say that IID independent identical distribution, or like what if you throw a coin or throw a dice. So the outcome of each turn is independent to the previous one. However, in the realm of generating a text or an image, or for image, each item or each element is a pixel. Each pixel, if we from the left to right and up to down, up to from top to bottom, then each pixel are correlated to the previous ones. So in this case, the items, the elements are related to the previous ones. So we need a model, or at least we can have a model that by condition on the existing elements, then we can predict the future ones. We can predict the future ones. So this is basically the models that we are going to call it autoregressive models. So let me go to the whiteboard and explain it more in detail. So let me get my whiteboard. Okay, so we have this one. So suppose also in the previous formula, we have a px, right?
So let me consider a more specific case. Suppose we have a sequence of 4 elements, have a 4 element, x1, x2, x3, x4. So usually when we consider a formula or a more abstract form of mathematical theory or just some number of symbols, we usually relate this kind of symbols with some examples. Usually you need 3 examples, but right now I'm just going to give you 1 example. For example, each x1, x2, x3, x4 is an English word for this is a book or that is a pen. Or any English sentence with 4 words for like I ate apple, like this one. So the space we are considering is English sentence with 4 words. The first one is x1, and the second one is x2, and the third one is x3, and the first one, the last one is x4. So each of these x1, x2, the whole thing is called x. So given any combination of English words, we can give a probability that if it is nature or is actually an English sentence, we can give a probability of that. So something like so this 3 is more likely to happen because it is kind of a valid English sentence. So when we consider people just simply write 4 words and has to be an English sentence, it has some decent chance to appear. However, it's something like just say ball, pen, ball pen might be something valid. So ball, rocket, car, 10. So this makes less sense. So the probability of this being right by a person, that when the person trying to write a sentence of 4 English words, then this is less likely to appear to be in the samples to happen. So we can have a probability of this kind of guys. When x1 is the first word, x2 is the second, x3 is the third, and x4 is the last one. So we can give a probability of this sentence. So this probability is kind of complicated because there are no obvious rules of what should be. Of course, we can make some complicated rule like because it only has 4 words, so the grammar only needs some like a verb at some place, and some noun at some position. We can do something, but it is complicated enough. At least it's more complicated than the thing that like if we just randomly flip a coin or randomly throw a dice and those kind of things. So how do we kind of handling these things in using like a neural network or other models to do so? So one way to do that is first we can actually compute the probability doing the statistics, like we collect like 1 million, 10 million, or 1 billion samples of that kind of sentence, and we simply just do the statistics on the first word. So maybe you can have a things like a table, like, okay, the first one is this, has like 3% of probability, and the second it is I, you, that, or maybe like 1%, 2%. This is just an example. So maybe something like this one, that you have a complete list of the first one, and we can do that. So for the second one, because we cannot do the second one separately, so I mean, of course we can just simply do the x2, but we wish to generate the whole sentence. If we doing the statistics independently for the x1 and for x2 and x3 and combine them together, this sentence might not, we might not be able to generate a meaningful sentence. For a sentence has only 4 words, it might have some decent chance to generate something meaningful. But this is just an example. We are really considering it's a longer length, a sentence with longer length. So a more clever way to do so is we consider then this kind of things. To consider the conditional probability. When given the first word, what would the second word be? So if we have a list, we might expect that the second one be a verb, like I, you, then. This one might be a verb. If the first one is like the, then we might expect the second one to be a noun. Or if this is a green or red, then the second one might be a noun, unless it is something like a green is a good color. This is 5 words, like it might be a be verb, or it might be a noun. But if this one is like a I, you, they, then the second one is more likely to be a verb. So the probability of the second one is depends on the first one. Then we can, if we collect like 1 billion sentence, then we might get some very accurate statistics for this kind of thing. So by given any of the x1, so we do the statistics separately for by condition on the value of x1, and we can have a different distribution of the x2 depends on the x1. So if we are given enough samples, we might have a very accurate estimation of what it is. So similarly, when we try to predict the third word, we are trying to condition it by the first 2 words. So again, imagine that you collect like 10 billion or like maybe 1 trillion sentences. You got enough sentences. So for each case, you have enough data to find the frequency of the x3 would be by given the first 2 words. So you can might have this guy. And for the last one, of course we might need more data, much more data to have accurate table for the frequency of what it will happen when given the x1 and the x2 and the x3. So by having all these conditional probability px1 and px2x1 by given the condition probability of given x1 and the probability of x2, and by given x1 and 2 and for the probability of x3, and this we'll combine these four guys together. Then we have a fully information about what the joint probability of px1, x2, x3, x4 is. So by having all these four conditional, the first one is not really conditional, but yeah, so most of them are conditional probability. By having these conditional probabilities, we can have the full information about the joint probability distribution. So you may have a question that it doesn't seem to be simplified. I mean, at least for this one. This one seems to be difficult enough because if you have to collect like trillions of samples in order to get the statistics, to have an accurate estimate of this guy, why not just have trillions of information and to calculate this directly? Okay, so this one is just one direction to do so. So in some cases this might. I mean, in general, this one is actually simpler. This one is actually simpler because this one has, in fact, it has less information than this one. If you know this guy, then you know this one, but not vice versa. So in principle, it actually sort of divide the problem a little bit, and we hope that we can create them separately. So at least this one is an approach, not necessary to be visible direct immediately, but at least it can divide the problem into several pieces, and hopefully we can conclude them separately. By contrast, in contrast to the models that we only compute or consider all these guys. If we only do the statistics or do to contrast the frequency table for these guys, this is not enough. This just like we generate each pixel together, and generate each pixel independently and put them together. Although this is definitely simplified the necessary of data and computations, but these four guys is not enough to reconstruct the joint probability that we actually are aiming for. These guys, especially these guys, is very complicated, but at least in principle they are simpler than the whole joint probability, and eventually if we have all of them, each of them, then we can reconstruct the joint probability that we are aiming for. So in this sense, the autoregressive model this terminology in this context is more like an approach that we decompose the joint probability. This is not the only way that we can do so. So for example, again we consider x1, x2, x3, x4 as English sentence with 4 words. We can ask different questions. So the question we were asking was like, given the first one, what is the second? Given the first two, what is the third? And given the first three, what is the last one? When I say what it is, I'm not asking you a specific question. I'm more like asking you what is the probability distribution of the last word will be. However, this is not the only way that we can decompose the probability structure. We can do alternatively. We can do something like this one. We can ask you a question. This is or this is a cross words to cross a sentence right here. Instead of asking what is the next, we can ask you what is the missing one. Also, it's sort of like if it is an image, it is like an impending or like a masked auto, like what we did for autoencoder is like a denoise autoencoder because we are given a noise. So if we have a model that can answer all these questions, then we can also reconstruct the whole thing. So when we say autoregressive, in our mind, it means it is not this kind of thing because there are many different choices. Although autoregressive is more like approach or a direction or a very broad meaning, but it does not. It does have some meaning because there are other ways. There are other approaches. One approach is like this one. If you have no idea what if you don't have this kind of alternative method in your mind, then autoregress pretty much means nothing to you because it's just probabilities, right? Okay. Because it is a joint probability, so we just simply decompose the joint probability into a chain of conditional probabilities. So what? The thing is, there are different choices. Like when you are at a crossroad, there are many ways that you can go. You can go forward, go left, or go right. So if you have only one way to go, then there's no meaning of telling the direction. Okay, you can go ahead or something because there are no other alternative. So you need to know there are some alternative, some other options. So this is one. So if you are considering about the denoise autoencoder, there's also something like this one. You can this car book. So in this kind of thing, we actually give you some specifically give you empty box, a blank box that you need to fill in. But in this one, we randomly choose one of the words to replace it by another one, which is supposed to be a wrong one. So you need to correct this one into find the incorrect one and replace it into a correct word. So maybe we can give you another text like this one. So this is more like a denoise autoencoder. So this can also construct a probability model, like given something, and it is more. I mean, the autoregressive model is more straightforward. But this one is also worked, but it's less straightforward. But this is an option, and kind of like we have seen it before because it is sort of like the noise autoencoder. So models like diffusion models is more like we say it's more like the noise autoencoder. So it works more like this kind of way. Or sort of like this one. We are asking, okay, if we got here already, we know the all other, like an image with all other pixels are. So what? Suppose we already know what other pixels are. Where should this pixel be? So what is the correct answer or the gradient? What direction should this pixel to be modified so that the image to be more realistic? Suppose we already know what other pixel was, what other pixel is. So this is more like the way that diffusion models do when it is on the noise phase. So in this sense, the autoregressive models, when we say a model is autoregressive, it means it is not the others. It is the one here. It is the simple one actually. Kind of meaning it is the we're not using some fancy method. We are kind of using a straightforward approach. It has something like similar to what I just said, like this one. We are trying to do this one in a more straightforward way to solve the complex structure of the probability. Okay, so let me go back to
the slide. So in this sense, the autoregressive, the phrase of autoregressive means that we are taking this approach, sort of saying that we are not using some more fancy or advanced processing. We are trying to use some more intuitive and straightforward way to decompose the structure of probability distribution. There might be some other straightforward way to, but by saying it is autoregressive, we know we are using this way, or just what we are seeing right now. However, in different contexts or in different field, autoregressive might mean something a little bit different. They are still more or less the same, but people are more emphasis on something different. So, for example, there's a terminology means ARP. AR means autoregressive. Also, it is actually called AR model for the length of P. It is often used in statistics. As I can see from Wikipedia, it also used a lot in econometrics or signal processing. It is specifically a model defined as following, like here, xt is equal to this kind of linear combination of previous one. So this is the autoregressive model in our previous definitions, but it is just the one particular kind of autoregressive model. It is a linear one, and it has some noise term here. This is white noise. This is learnable parameters that you can adjust. So in this context or in this field, when people say about the autoregressive model, they may mean specifically the linear one with this kind of noise assumption. There might be some other noise assumptions, but they are talking about the model with this, the linear model with a linear regressive, the linear autoregressive model with this kind of noise assumptions. So because this is the one that is very particular on the very specific, so there are a lot of properties that can be proved or derived from this formula, so we can actually compute something. And if you have a slightly different model, like adding some moving average or others, some integrate things, there are different names like ARMA or ARIMA. ARIMA is more popular one because this one is a more basic one, but this one is still someone that we can actually do the analysis analytically. So this one is a very popular one, and people still use it. It is not a deep model, but still kind of useful in many cases. You can see this model only consider the history that is cut off by the length of LP. So only you do not consider the whole history. You forget the things that are happened too long ago. So in this case, when people say, okay, we are using the AR autoregressive model, it means this model. Also, there are slightly different meanings in different contexts. You have to understand people have come from different backgrounds. They may mean something different. So this is some case that the AI model is capable of, like predict things. So this one is, I'm not sure what model is, but because it comes from a model that has a specific probability distribution has already defined in this formula. So the structure, so it actually can predict something that has an error band right here. So not only it can predict some value, it can only also give a range, like a confidence interval, or maybe just some deviation of the prediction might be. So it can actually give some probabilistic prediction, or not just a value of prediction. It also gives the prediction itself is not a number, it is a distribution, a time series of distribution. Okay, in the next video, we are going to give you some instruction of how do we actually implement the autoregressive model from this formula by using a neural network.